Okay, today's video we're going to talk about the senses of hearing and smell. Now, hearing is one that's a little bit less complicated than some of the others. Whereas the eye had to have all kinds of complicated things, the ear is very, very simple. Okay? The ear is designed basically to pick up vibrations in the air that would be too small for our skin to detect. Okay? And it's going to take those vibrations and the pattern in which they happen, send that pattern as nerve impulses to your brain. Your brain is going to put all that together and it's going to figure out, okay, this is what I'm hearing. Right? And that happens by, first, we run into the parts of what's called the outer ear. That's the part out here that we're used to. We call this our ear, but its technical term, it's got a couple of them, is our pinna. Okay? That's the outer portion of our ear that's stuck to the side of our head, is our pinna. It's sometimes also called the auricle. Okay? So this pinna or auricle, its job is simply to act like a cup on the side of your head and catch as many vibrations as possible and send them down this tube that's called your auditory canal. It's also sometimes called your ear canal. Okay? Now this comes in through this tube, and the end of that tube is covered by a very thin membrane like the head on a drum. Okay? And it's also stretched tight like the top of a drum. It's called your eardrum. Not a real complicated name because it functions exactly like a drum. What it's there for is to be beat on by these small vibrations in the air. As it's drummed on, it sends those vibrations through a series of parts. The next part of it, and notice that this is where the air stops. This vibration now becomes a part of our body. We're shaking pieces inside of us now. Eventually what we want to get to is a point where we shake nerves that send signals to our brain to interpret. Okay? So we change from air into shaking parts with the eardrum. Very, very sensitive little piece of tissue there. Okay? It's stretched very tightly, has a lot of nerves in it. Okay? This is why you dig in there and you clean your ears too far and you hit your eardrum, it's going to hurt. Okay?
Yeah.
And it's why you don't want to be digging around inside your ears because it's easily damaged. It's so, so thin. Painful, 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 easy to damage. Don't want to mess with it. Okay? When we get past the outer ear where the signal stops being air vibrations and turns into vibrations of pieces of us, we have an area in here called the middle ear. Basically it's a little pouch. It's got one side that's the eardrum. It's got three little bones in here, okay? Now those three little bones are called your auditory ossicles. Your vocab words. Auditory ossicles, basically, they're a series of bones that one of them rests right on the back of the eardrum. When the eardrum gets hit, it pushes the first bone. First bone pushes second bone pushes third bone. Not a real complicated system here. Okay? But that third bone rests up against a chamber we call our inner ear. It's actually three different parts here, but what they are is essentially kind of a complicated water balloon that's tied to a bunch of nerves, okay? We'll get back to that in a second. I want to show you these auditory ossicles for a second. That's how big they are. That's a penny.
What kind of penny is that?
I believe it's English. It may be Canadian, not sure. But it's a small coin. All three bones easily fit on it. Okay? Now, those bones actually have other names. One is called the hammer, the anvil, and the stirrup. They've got scientific names, but see how it looks like a stirrup? This is the one that rests up against that inner ear portion, okay? Now, I'm going to show you a slightly different version of this, okay? This is your three auditory ossicles over here in this pinkish color. This is your eardrum cupped here. Eardrum hits the first one, hits the second one, hits the third one. Third one drums on the side of this blue organ. And it's not actually blue inside your body, okay? It's just colored blue in this picture. Now, this piece here, like I said, is a really complicated water balloon, essentially. It's got three parts. The one that we're really interested in for hearing is this snail shell looking part over here that curlicues in on itself. It's called the cochlea. That's one of your vocab words. Okay? That cochlea is a water balloon filled with fluid. But on the inside of that are a bunch of cells that are attached to nerve cells. And these cells sit there, they have little hairs sticking up off the top of them. Well, those little hairs, they're sitting inside that fluid, inside the water balloon of the cochlea. When the bones tap on the outside of this water balloon, the fluid inside shakes. Well, what that does to the hairs is the hairs start going back and forth like this. Well, those act like an on and off switch on a nerve. It's, oh, we got pushed, on. off, on, off. And so it sends a pattern of vibrations. Your brain can sort out vibrations that happen as slow as about 20 of those a second. So that's still pretty fast. 20 on-offs in 1 second. It's pretty quick. All the way up to as many as 20,000 of those in 1 second. Your brain can figure that out, and it considers it a sound. Okay? Now, just to understand that, those lower numbers, those 20s, also are lower pitched sounds. So the slower the vibration, the lower the sound. The faster the vibration, the higher pitched the sound. Okay? So something that would be at like 20,000 vibrations a second is that weird, you ever hear that really weird high-pitched thing that comes off of a TV when you first turn it on or when you turn it off? That background noise? Yeah. That's about 20,000 hertz. It's right on the edge of what human ears can figure out. Okay? And then low rumbling noises that you'll hear as background music in some high bass songs, you'll hear that. That's down at that 20 area. If it's less than 20 vibrations a second, your skin actually starts to feel that, and you feel that as a shake rather than as a sound. Okay? Now, what goes on inside the cochlea? That's where all the nerves are wired up. That's where on, off, on, off, on, off, and those patterns as it gets drummed on and those things shake are what your brain gets as nerve signals. It takes those patterns and it goes, oh, okay, that combination of things, I've heard that before. That's Mr. Duncan's voice. And so you can hear me. Okay? And you understand what that sound is. Or you interpret those vibrations to make that, or a clapping sound. The vibrations that come off of that. The different patterns are what your brain turns into different kinds of sounds. Okay? Now, there are two other parts to this water balloon, though, that are worth mentioning. Okay? You've got the one that's directly right behind the bones, the part that directly is getting drummed on. This is the part that helps us understand loud and soft. This part is called the vestibule. Anybody notice anything yet? We got the vestibule and the cochlea, and then we got a nerve that's attached to both of them. Does that kind of ring a bell as... Nice, I say ring a bell and the bell rings. Kind of ring a bell as our last vocab word? The vestibulocochlear nerve. That's the nerve that wires up these two pieces. Okay? This is the nerve that goes straight to the brain from your inner ear. This is what sends sounds, as in how loud is something, how soft is something, how big are the hits that are hitting on this water balloon, and then how fast are the vibrations, because it measures how fast it's being traveled through this. Okay? So those vibrations turn those things back and forth, and your brain interprets those patterns into sounds. Okay? Now, these loopy things over here look kind of goofy, don't they? Kind of a weird water balloon. Those are what's called a semicircular canal. And by having those arched like that, what your brain does is it's actually able to take information from those and how the fluid sloshes around in those to help tell your brain whether you're standing upright, whether you're moving to the side, moving front to back. They're what control your balance. That's why if you have damage to or an infection to your inner ear, you can get dizzy. It's because you get dizzy when your balance is all out of whack and you're stumbling around and doing funny things, or when somebody spun you around so much that the fluid inside those is all swirled up and your brain is going, whoa, hold it, too many mixed messages, don't know what's going on, and so we get dizzy. Okay? And so that's the kind of thing that can happen up in here. The fluid that's in these semicircular canals is what helps keep your body balanced and coordinated. Okay? All right, so that's basically how the ear works. Let's go on and talk smells. Okay? Let's talk noses now. Just wanted to show you a little bit about how the nose is put together. This is a side shot of the head. Your nasal cavity is actually a fairly big place inside the bones, inside the front of your skull, okay? But it is not just one big, open, empty area, okay? There are actually, you can kind of see these lines in here. They represent folds. And if you look here in this one, and you guys do have this in your My Big Campus Resources section, so you can look at this more closely on your own. These folds in here, basically what it does is it acts as a way to channel the air as it goes in through your nose, so that part of it will go down your throat. And it will take part of it, though, and it will channel it up to the top of this chamber. And there's a reason why. At the top of the chamber is where our brain connects to our nose, okay? Because I want to take a look. Look at this. This is your brain up here. This bone that we're talking about runs right here along the bottom, okay? So what you get is when you breathe in, air gets brought in through your nose. Part of it goes down one channel and is headed straight down to your trachea. The other part goes clear up here so that it gets pushed past that bone. Because that bone is a very special bone. It's called the ethmoid bone. It's got holes in it. Because up here on the other side of that bone is your brain. Okay? Get a little closer look here. And a projection that comes off of that brain called your olfactory nerve. Olfactory is the word for smells. Okay? For your nasal passages. For scents. Okay? Well, that branch off your brain sits right on top of that ethmoid bone. And the dendrites off of a bunch of its nerves actually go down through those holes in the ethmoid bone and into your nasal cavity. They stick down in there. Somebody last hour referred to that as looking like a really nasty toothbrush. Okay? It kind of looks like an overused toothbrush, doesn't it? Okay? Well, those nerves stick down into there. Well, what happens is when you breathe in, part of that air is forced up here and across those nerves. Well, any chemicals that are in those air particles that you bring in are going to be forced past these nerves, past these dendrite endings on these nerves. Well, different chemicals hit different ones of these, and it sends an electric signal. It sets off those nerves, sets off the dendrites, and right up into that olfactory nerve, and right back into the brain. Okay? So basically, what you're smelling is chemicals that are touching the nerves that are almost directly attached to your brain. Okay? So the chemicals are actually touching the nerves themselves. There aren't steps like you have and things to go through, like in the eye, where you had to go through the cornea, and through the pupil, and through the lens, and through the vitreous humor, and hit the retina, and then the retina sends that signal back through your optic nerve, or through the ear, where you've got the eardrum, and the auditory ossicles, and all those sorts of things. You don't have those here. This is a direct chemical hits the nerve, nerve goes off, you get a pattern in your brain. Your brain goes, ooh, yummy, pizza, or skunk, because it's able to recognize the types of chemicals that have hit these nerve endings. Okay? Now, most of the time, these nerve endings are branched out here, and they're covered in mucus. So the reason why smells will kind of stay with us, or we can kind of think our way through what those smells are, is those chemicals will get caught in the mucus. Yes, the mucus is better known as snot. Okay? Get caught in that mucus, and it'll float around near these nerves. Okay? So, there you are. That's the basics of how ears work and how your nose works. All right? So we can go ahead and shut off the video.